Back. Today we're going to talk about conic sections, and we're going to talk about just the first part and some of the general things like what are the equations, what do they look like, and some of the general stuff regarding conic sections as we head into chapter 8, which is all about conics. So one of four things could happen. We've got two cones. There's a cone, so right here on the bottom is a cone, and then there's an inverted cone. So they intersect right at the point of the cone, the vertex of the cone. And if we take a plane and we slice the one or both of the cones, we get the conic sections. Conic meaning of the cone, sections, right? And so the first thing that could happen is we slice it parallel to the base. So a circle is sliced parallel to the base. Okay, so it's sliced parallel to the base. So the circle, as you can see, it could be really small or it could be all the way down to the bottom, so it'd be a really big circle. A parabola is diagonal through one cone. So that'd be diagonal through one cone, and it's got to go, out the bottom. Okay, so it's got to go and touch that bottom circle. An ellipse would also be diagonal through one cone. Okay, and a hyperbola cuts both cones. So that's perpendicular to the base, one or both bases. Okay, so those are the four different kinds of conic sections. We're going to start with what a parabola is. And so we see that it's diagonal through one of the cones and it's got to go through the base. But the technical definition of a parabola is all points in a plane equidistant from a particular line called the directrix and a point called the focus. Okay, what would that look like? Well, check this out. If I've got a line here, and I'm going to draw it in green. Here's a line, and I'm going to call this my directrix. Okay, there's my directrix. And in red, I'm going to put my focus here. Okay, there's my focus. My parabola is actually going to look like this. And what I'm measuring is right here. So this is my vertex. And that's just one of the points on my parabola. So really what it is this distance here equals this distance here. And for example, this distance here is equal to this distance here. And obviously my drawing is a little bit off. But what happens is I put a point on the parabola, or there's a point on the parabola that's equidistant from the directrix and the focus. So I can draw these sets of two lines that make up this entire parabola, and these two sets of lines intersect at where the parabola is equidistant from the focus and the directrix. As you can see down here, we're going to talk specifically about this line here and what those distances are. But that's the nature of a parabola. It's all of those points that are equidistant from. And so this one that happens to go through the vertex and the focus is called the axis. And that's that point where we can fold that parabola in half on itself. And so if I draw another picture of this situation here, I'm going to have just kind of like a coordinate plane sort of deal going on. I'm going to draw my parabola in like this. And what I just told you was there's a point, that's the focus. I'll put it in red also. My focus. Oops. And my directrix is down here, so it's going to be something along these lines. Green. Here, yeah? There's a couple of significant distances here. The first one is that this distance from the focus to, or sorry, from the vertex to the directrix is P, and from the focus to the vertex is also P. So those distances are the same. Well, notice over here, that's what I just said. From the directrix to the vertex and from the vertex to the focus, those distances are the same. That's actually going to help us define the equation for a parabola. So the equation is going to be x squared, and it's an x squared if it opens up or down. X squared equals 4py, where p is the distance from the directrix to the vertex. Directrix. And here's the cool part. The directrix is y equals negative p, right? Because negative p is going to give me p distance away from wherever this vertex is. Okay, what else could happen? Okay, so the opposite thing could happen. So we could have a value here, and we're going to put it in our coordinate plane. Draw in my directrix here. Y equals negative p. And notice it's going to be above this time. And so I've got to monitor my distance here. So this is going to be my focus. I'll draw my coordinate plane. Sorry, my parabola in here. And notice, I'm going to label my distances here. So from the focus to my vertex, and from my vertex to my directrix, both P, right there. And so the same thing exists whether it opens up or down. So this is still x squared equals 4py. Well, how could this possibly be? Well, in this case, my p is going to be down, so my p is going to be negative. So opposite of p would be positive, so my directrix would be up. Okay? And so there's some relationships that exist here. We're going to explore the parabolas with the vertex of 0, 0. So x squared equals 4py. Okay? This would open up or down. The other way that could happen, it could be y squared equals 4px. Well, that would open left or right. Yeah? If my parabola has a vertex at 0, 0, my focus is going to be at 0p. And if my parabola, so then if I have a y squared, it's going to be p comma 0. Okay, so my x coordinate would be the one that's changing, or my y coordinate if it opens up and down. My directrix is y equals negative p. My directrix here would be x equals negative p. Well, think about that. If this is, it opens left and right, so my directrix would be here. My focus would be here. This would be, let's call this, my x-axis or whatever. My vertex, think about that. This is an x equals line, right? And this would be a change in the x coordinate to get to my focus. My axis is my y-axis here, because this one opens up and down, remember? So my axis would be my y-axis, and this would be the x-axis. Focal length. My focal length is distance vertex to directrix, right? So that would be p. And in this case, also p. Distance from vertex to focus is p. My focal width is the absolute value of 4p. This is my absolute value of 4p. So we're going to look at how that changes in our parabolas with a vertex that's hk here in just a minute.